camera so the sharing session to be more engaging. And number two, please mute your mic when not speaking unless you have a question to ask our instructor. And number three, please leave a question or inquiries into the chat box and our channel Dr. Carol will deliver their best. Also, we will encourage all participants to have active engagement and happy learning through the sharing session. Okay, without any further ado, let's welcome our talented trainer and subject matter expert, Dr. Carol, to start the course, and I shall pass the platform to you, Dr. Carol.
Thank you, Mr. Nassim. Thank you. Assalamualaikum and very good afternoon, everyone. Let me share the screen first. Can you see the screen?
Yes, Dr. Carol.
Okay, good. Okay, my name is Khairul, and today I would like to share on discovering machine learning with the Python Power Intelligence. Okay, so we are going to explore using the Python to apply the machine learning to solve the problem. Okay, so basically this is the objectives for the sharing. To brief the Python installation procedure, and then we are going to develop the machine learning model. Okay, so basically this is the step that we need to apply when we want to develop the machine learning model. The first one is we need to import the data, and then we need to clean or to prepare the data. After that, we are going to split the data into training portion and the test portion. Okay, training part and the test part. Afterward, we can create a model. Okay, to create a model, we need to understand first what is the purpose of our training, and then what is the purpose of the problem that we need to solve, and we also need to understand the data first. Okay. So basically, to create a model, we have three types of the learning model. The first one is supervised learning. The second one is unsupervised learning. And the third one is reinforced learning. So we need to make sure we choose the correct model. So after we create a model, then we can train the model, okay, by using the data that we have. Okay, so it's meaning if we use the data, it means we choose the supervised learning method, right? And then we can make the prediction, or we can test our model, and then we can proceed with the next one, which is to evaluate and improve our machine learning model. Okay, so basically it is the library that we need to use when we apply machine learning in Python. Okay, the first one is a NumPy, and then the second one is a Panda, and the third one is Seaborn or the Matplotlib. Okay, which is this library we use to plot the data. And then we are going to use the scikit-learn library, which is the common library that provide us a lot of algorithm machine learning model, so that we can use to develop the machine learning model, right? So this is the reason why we prefer to use the scikit-learn in the Python. Why we prefer the scikit-learn library in Python. The first one, because the library is a lot of different learning model, a lot of algorithm. Okay, so currently the library in scikit-learn can cater different type of learning model, either supervised, unsupervised, or the reinforced learning. Okay, so we have a lot of reference that we can refer to develop our project. So of course, the second reason is the variety. We have a lot of sources library that available in the scikit-learn library, and then the stability, the fast process, and the big community. So we have a lot of developer, a lot of programmer that use the scikit-learn, that they always share their thought, share their feedback on the scikit-learn library, so that we can learn each other to improve the machine learning model. Okay, so I want to touch a bit before we proceed with the machine learning model in Python. For those who maybe the new beginner want to explore the Python, so you need to install your Python first in your machine, in your laptop or your desktop, right? So what you need to do is, the first step is you go to the Google, and then you need to go to the anaconda.com. Okay, so you go to this software, to this website, okay, and then you can start to download. Okay, download the Anaconda based on your OS, either Windows, Linux or the iOS, right? Okay, once you go download, let's say in this environment, I'm using the Windows platform when I install this software, and then you can once you download, okay, you go to the installer that has been downloaded to directory, and then you go to that installer installer, and then you can proceed to installation process. Okay, so once you install, then you can go to the next step, which is you just click the next button. Okay, the installation procedure is quite straightforward. You just need to install the software by using the common method. Just click the next button and agree the license agreement and so on, right? And you just click either one, so both work for you. Okay, and choose the directory where the Python software will be installed in your device. Okay, and then after installation is done, okay, then you can launch the Anaconda. Okay, just click the button until finish, and then you get, once the installation procedure is finished, then you can go to the Anaconda in your search software, and you can click this one, Anaconda Navigator. So and then once you click this Anaconda Navigator, so it will show you the software that available in Anaconda Navigator. Okay, right now let me share. So in this project, so in this sharing, basically we are going to develop okay, few project using the machine learning model in Python. Okay, the first project is we are going to develop the machine learning model that able to predict the favorite genre based on gender and age. Okay, so we are going to predict the favorite entertainment basically, okay, based on gender and age, right? And then we go to the next one, the project number 2, you are going to predict the score mark based on learning hours. Okay, and then the project number 3, we are going to predict the house price based on the house size. And project number 4, we are going to predict types of flower iris species by using the machine learning model. So there are 4 projects. Hopefully we can complete this 4 project in these 2 hours, so then you can explore, have an experience for programming, for coding, how to use the Python for machine learning model, right? So let me stop this screen first. Okay, let me show you the screen. Okay, okay, so since right now I'm using the MacBook, so I'm going to show you how to open the machine learning model. Okay, so let's say if you are using the MacBook, so just go to the find the Anaconda Navigator and just click this one. So this windows will open for you. So that what you need to do is you just go this Jupyter Notebook. Okay, so when you click this Jupyter Notebook, so this is the IDE environment. So this is the platform that we're going to use to develop the machine learning model using the Python. Okay, so just click this one. Okay, there are a lot of IDE that available in Anaconda. Okay, we have the JupyterLab, we have the PyCharm, we have the Spider, right? We have the Spider. So this is all the IDE that we can develop the machine learning model for Python. Okay, using the Python. So this is all the environment or the platform that we can use. So the reason I'm using the Jupyter Notebook is because the environment is quite clean. Okay, it's very easy to show the data, and it's purposely designed the platform to develop the machine learning model that based on data analysis. Okay, so this environment is quite clean and very easy to observe, right? Okay, and yeah, once you click this one, okay, so what happened is, so this one will be appear in your machine. Okay, so what you need to do is you go to the folder. Okay, so this is basically the first page when you launch the Jupyter Notebook. So this is the first page will be appear. So what happen is Jupyter Notebook will display to you all the folders that in your machine. So to make it easy, so everything the coding that I want to develop, everything the data set that I'm going to use, all that files or folder I put in at the desktop. So you can do the same because it's a common directory. Either you're using the MacBook, either using the Linux or using the Microsoft. So everybody, so we just use the desktop so that we can easy for us to do to refer the programming file or to retrieve data that we store. Okay. Since our first project is number one is to predict the favorite genre based on the gender and age. Okay, so this is the first project we are going to develop. Okay, what happened is, so I have a lot of data here. Okay, let's go to this one. So we go this one. Okay, we'll go this project number one. Okay, so let me open this one first. So let me show you the sorry. Okay, let me show you this one. Okay, so this the program that I developed to predict the favorite genre based on the gender and age. Okay, so as you can see here at this folder, so I have this file where this file have the data set. Okay, so in order to import this file into the Python, so I need to use this one. Okay, not this one. Sorry. Okay, this one. Okay. So, okay. So to import the data, I need to use this function. Okay. Okay, I need to import the Panda. Panda is the library that we need to use to manipulate the data so that we can use this Panda library to show the data, to arrange the data and so on, right? So we need to import the Panda library as PD. So before I proceed all the programming, the code, let me explain a bit on how let me explain the brief what is the environment of Jupyter Notebook. As you can see here, this all the tab. Okay, so this file is give you the option to open the new page so that you can open the previous file that you just programmed before. The new notebook and Python 3 is the way how you're going to create a new page for Jupyter Notebook. So let me click this one. Okay, so if I click this one, so this is the first page. So the first page of Jupyter Notebook, right? So this is where we can write the program that we want to develop. Okay, so under this one we have all the function to save the file, to rename the file and so on, right? To edit, to copy the coding from one block to another block, right? To insert the cell. So this is a cell, this is a cell. They want to insert the cell above or below, right? And then to run the specific cell or to run all the cell. Okay, so we have this option under this tab, right? So this is the shortcut to run the run button so that you can compile and run your code and so on. So this is where you want to write your program. Okay, so to make it easy, if you want to import the data, make sure the program that you want to develop is the same folder with your data set. Okay, for example this one, so let's say this is my file, okay, genre under this project 1 folder. So basically you can create beforehand. Okay, you can create first at your desktop a specific folder And then once you open the Jupyter Notebook, and then you just go to the desktop. For example, right, I click, for example, this one, the first page, right? So I go to desktop and then go to the my folder, right? And then I go to this one, generate, and then this is project number 1. So we can create this first. Okay, we can create this first before we start Jupyter Notebook, so that we know where is our data set. Okay, so once you create this one, okay, let's say you go to this one, you want to create a new page, a new notebook, okay, a new IDE environment to develop the machine learning model where your data been located. So at the moment, my data is at this folder, right? Project 1, generate. So I want to develop the Jupyter Notebook, the same folder. So what happen is I go here, and then I just click here, Python 3 IP kernel. Okay, so this is my Jupyter Notebook. So I just close the previous one, right? So here you can create, you can rename here. You rename this Jupyter Notebook file name, because this one untitled number 1 is the default name for new notebook. Okay, maybe you can create this one machine learning project 1, for example. Okay, project 1, for example, right? Okay, and then you can rename it. Okay, so this one is machine learning project 1, for example. Okay, so if you notice here, the previous the notebook, the Jupyter Notebook they just created is now available here, the same folder under project 1 folder, right? They just created, and then now this file has been created at the same folder. So definitely now your Jupyter Notebook, okay, machine learning project 1 is the same folder with your data set, so that you can easy to retrieve the data. Okay, otherwise you can specify the path to import the data. Okay, right now, so what we want to do is to develop the machine learning model to predict the genre or the favorite entertainment based on gender and age. Okay, the first one is we need to import the data, right? We want to import the data, so we need to import the library that allow us to import the data. So what happened is we need to import the library first. So we need to import the pandas library, okay, SPD. So this one I want to simplify the pandas library SPD. So next time I no need to write down the pandas for full spelling. Okay, and then I'm going to using this pandas library to read my CSV file. Okay, CSV file. Okay, and then I need to tell what is the file name. The file name is here. Okay, the file name for my dataset is genre.csv. Okay, so now I need to park this one under one variable, so easy for me to call the data after this. So now I'm going to call the library. Okay, so you can run this one. Okay, so basically if this you click the run button, and then the next cell show you without any error notification, it means your program has been successfully compiled, no error, right? So to show the data, we just need to write down again the variable that we just park our data. Okay, run again. Okay, so basically this is the data that we have. Okay, right now, okay, I have the age. Okay, I have the age from 20 years old, 23, 25 until 58 years old. So for each age, based on the data that has been collected, different age have a different favorite of entertainment. For example, this one from 20 to 25 years old, they like hip hop. Okay, and then from 26 to 30 years old, they like jazz, and so on. So every age like different type of genre. Okay, now we have this data, right? So we can create a software, okay, so that software can predict the favorite music or the favorite genre okay, genre for for that person, so that that software able to predict, so can suggest the list of music that people like. Okay, let's say you want to develop a software like Spotify, right? So once the people subscribe the software, they will fill up their detail, for example, the gender, the age, right, and so on. So based on that information, you can suggest the list of music that they like. So this one will give the pleasure and nice user experience, because your software can suggest the correct suggestion, right, the correct list music suggestion. So that is the idea. So we want to develop that example of software. We want to develop the machine learning model that able to predict the favorite music. Okay, the favorite music based on age. Okay. Now we already have this data, and so far our data is clean, no issue, because at age we have all the numbers. Okay, because age represent the number. Okay, so there is no error, and all the column have the number, so no error. And the genre also have the specific information for each data. So at this moment our data is clean, so we can straightforward to go to the next step, which is to split the data into input and output. Okay, because we want to predict the favorite genre or the favorite music based on age. Okay, so if we want to so this means the age is input and the genre is a output, the music is an output. Okay, so we need to split this first. We need to split into input and output. Okay, now so since we have already import the data, and our data is parked under this variable music underscore data. Okay, and then what happen is we need to decide which is input. Okay, at this moment for this graph, the input is age. Okay, the age column, age is the input, right? So we need to drop the genre column. Okay, what you need to do is we need to call our variable, okay, music data, our variable, and then we need to drop, okay, to drop the column that we no need. So to drop the column, we need to tell the item to drop the column. So which header, okay, which header. So the header that we don't want is the genre. Okay, this is we want to drop. Okay, and this one we will park into X. Okay, so X is a input. Okay, X is input. Okay, so now X will equal to age, right? Because we drop the genre column or music column, right? So we can run this one. Okay, so if we call the variable, so this one will show us the data. Okay, now X equal to age column only. Okay, age column. So this one X is the input. Okay, we have the input, right? Now the next one is we going to call the output. Okay, previously now we decide age as input and genre as an output. So we need to call the output. To call the output, if we just call the y, we just put we call our library, our variable first, music underscore data. Okay, and then we call our header, which is genre. Okay, and this one we need to park under one variable as well, which is y. You can put any variable that you want. So this one is y. Okay, so now y as a output. Okay, so we just call our variable to show our data. Okay, so now this is a variable for output: hip hop, jazz, classical, dance, and acoustic. This kind of the entertainment or genre the people the output. Okay, so X as an input and Y as an output. This is a data set. Now we have the data set. We already split input and output. Okay, so once you already split the data, so what happened, what you need to do the next is we need to we need to follow the training and prediction. So this is what we're going to do. Okay, training and prediction. Alright. Okay. So to train our model, we need to call the model, right? To train the data, we need to call the model, right? Remember the step, we need to call the model. We need to choose the model. Okay, from this one we can choose, for example, we use the library as sklearn dot from tree. Okay, library. So the algorithm is import decision tree classifier. Okay, so we are going to use this algorithm, okay, to classify. Okay, and then what happen is we need to park this one. Okay, decision, we need to call this one decision tree classifier. We need to call this one as a model because we want to use this one as a model to train our data. Okay, so once we have this one, okay, no issue. So far I just run. Okay, then we can use this. Now this algorithm, okay, this algorithm has been parked under model. Okay, so next time we just call the model to train the data. So we just call the model to train the data. We're going to use this one, model.fix our data x.values.y. Okay, so we're going to feed this model. What model? Decision tree classifier for this input and output. Okay, that is what we're going to do. So these are all the what's where the magic happen, where this algorithm will feed the learning model with the data, right? Okay, so now let's try to run this. Okay, so something spelling error. Decision tree classifier. Decision tree classifier. From sklearn.tree import classifier music model decision tree classifier. Okay, model.fit x.values y. Okay. Okay, so far no problem. Okay, because there is no error. Okay, so it means now we already feed this decision tree classifier for data input and data output. Okay, now what we need to do is we need to do some prediction. Okay, remember the data that we have. Okay, we have, if let's say now we already train the data. Okay, so they train the data. Okay, and then we're going to have this one. So we want to predict the model by using the data. Okay, now we need to call the model again, model.predict. Okay, model.predict, and we want to predict, let's say I want to predict what if the age is 20, what kind of genre the software will be suggest. Okay, based on the data should be hip hop. Okay, so let's try. Is it our software can predict correctly? Okay, this one, so it allows for us to see the data. We just need to park under one variable. Okay, prediction. So okay, this is an error. Okay, need to model.predict. Okay, prediction, and then we need to this one we can try to predict another age, for example. Okay. Okay, no error. So from sklearn.tree import decision tree classifier and the model decision tree classifier. Okay, and then we're going to model. Okay, model decision classifier, and then model fit with the value from our data. Okay, and then we need to call our data. Okay, is it underscore data. Okay, prediction equal to model the predict, right? And then we can go into prediction. Okay, now we already success to call test our data. Okay, so if 20 years old should be based on the data hip hop. Okay, and if the data is 35, okay, 35 is between, based on the data we don't have 35 years old, but based on the data set 33 years old would like classical, and 37 years old also would like classical. So it's meaning by logic 35 years old would like also will be like classical as well. So when we test our model, so when we put the age 20 years old and 35 years old, we also the model able to predict correctly. So 20 years old would like hip hop, and then 35 years old would like classical. Okay, so this is how you can predict. Okay, we can predict the data so that we can predict the age and to have the output. Okay, so let's try another one. Maybe we try 40 years old should be like dance, right? 40 years old should be like dance, and then we try 54 years old would like a cappella. Okay, right? Okay, at the moment so far our model able to predict correctly based on age. Okay, that is the idea. Okay, now let's say what if I have more data, more input, more than one data. This one based on age. Okay, based on age. So we have another data set, we have the genre. What happen if we have two input? Right, this one single input, single output, right? Single input, single output. What happen if we have two input? Maybe we have another input which is the gender. Okay, we have the information of age and also the gender. So based on this kind of data set, how we going to develop the machine learning model so that we can predict what kind of the entertainment that people like based on their age or their gender. Okay, so go to this one. So this one previously developed. Let me open this one. Okay, the same process. So we have also have this data. Okay, and I have this data, right? So I have the age and I have the gender. So now I have two input. So based on one, consider we can consider one as a male. Okay, one is male, and then number 0 is female. Okay, female. This is kind of data mapping lah, because the Python cannot process, cannot compare base for these pandas. For panda library cannot compare the string text data, so we need to convert from string, for example, from male into 1, from female to 0, because we're using the pandas library. The pandas only can process the numerical value, that number value, okay, numbers. So that's why if the output is, if the input is 1, it means male. So if the input is 0, it means female. So in this case, we have the data set. If the age is 20 years old and 1, which is male, it will like the, so this guy would like hip hop. And if the female 20 years old, she like dance. Okay, so we have the different data, right? Even though they have the same age, but because they have a different gender, they have different favorite. So they have different preference. Okay, so we are going to develop this software. So basically, yes. Okay, now you can see which one will be more accurate, single input or two input. Okay, so even though we can develop the correct machine learning, they're able to predict accurately based on data set, but basically we don't know the gender, right? So maybe We don't, even though they're 20 years old, we have the hip-hop, but based on what happened if they have different gender. Is it boy also like hip-hop or female also like hip-hop? We don't know because the data set is fixed to one variable only, one input. So that's why for this one we have more, that data is more dynamic compared to the previous one. We have the age information and we also have the gender information. Alright, so that we can predict more accurately. Sorry Tengku Amira, Yasmin, I'm not aware you are coming. So Tengku Amira, so far anything that you not understand? Is it okay so far? Any questions? Okay, I guess no questions. So Tengku Amira, if you have any question, just raise the question so I will answer your uncertainty accordingly. Okay, so now we have previously, Tengku Amira, previously we developed the machine learning model to predict the favorite genre based on their age. Okay, single input. Okay, now we want to develop the machine learning model, okay, based on two input. We have the information of their age and gender, right? So 1 is male, 0 is female. The reason why we use 1 and 0 because now we're using the pandas library. Pandas library can accommodate, can process the number only. That's why we need to convert from male into 1, okay, female into 0. Okay. Now, the same process. The first one, we need to import the pandas. Okay, we already import previously. Just write down again so that we can have the nice flow, the programming during explanation. So once we import the library, panda library, and then we import this data, right? Because now the second step is we need to split the data into two parts, input and output. Okay. Now we need to drop the so we have the input. Okay, so this is our input. Okay, we need to drop this one. Okay, genre. Okay, this column, right? Okay, so we only have this input, age and gender. Okay, we drop this column. So and we park this one as a x variable. Now we have two input, age and gender. So x as an input, where this x have this information, the age and gender. Right? Now we already define the input as x. Next we need to define the output. Okay, to define the output we just call our data in which header. Okay, so the output obviously this one. Okay, the genre. Okay, and then we just call this one, we park under y variable, so y as a output. Okay, so we run this one and then we have the list output. Okay, at this moment the Python already store the value of x and store the value of y, where x is input and y is a output. Okay, so once we already split the data into two parts, input and output, now the data is ready to be trained. Okay, to train the data we need to import the machine learning model. So in this one we using the same machine learning model, which is the decision tree classifier under this library. Okay, and then we call, okay, with this one the input and the output as mentioned previously. And then this algorithm, okay, this algorithm, okay, decision tree classifier, we park under model. So next time we just call the model because the model itself is the decision tree classifier algorithm, right? And then we use this model or this algorithm to feed with our input and output. Okay, to feed with our input and output. Okay, and then we call our data, right? And then we predict, okay, predict our model based on model with this information, right? So this one is 21 years old, okay, male, and 22 years old, female. Okay, So once I run this one, so the result is hip hop for this input and dance for this, dance output for this input. Okay, let's see the data set. Is it correct? 21 male, 21 male, which is the between for this one, right? 21 should be like hip hop. Okay, 21 years old and male should like hip hop. Okay, so now I run this one, right? So I have this result. So the result show correctly. Our machine learning model can predict the output based on age and gender. Now the next one, 22 years old female. So let's see the database. 22 years old female, which is 0 here. 22 years old should be in between here. 21 done, 25 0 done. So 22 years old female should be like done as well. So now we just run this one. So we have this output. So it's meaning our program able to predict the favorite genre based on the age and gender correctly. Okay. Now the next one is we need to measure the accuracy. So once our already trained the model and our test the model, so we need to make sure our models is reliable. Okay, we need to make sure the percentage of our accuracy is sufficient. Okay, is sufficient with the tolerance. Okay, to measure the accuracy, we need to import the train test split library. Okay, train test split algorithm under this library. Okay, and then we can import this algorithm, okay, under this library to measure the accuracy our machine learning model. So we need to use this coding. Okay, this coding, okay, x train, x test, y train, y test, train underscore test underscore split for our input and output, where the test size is 0.2, which means 20%. Okay, so it's meaning, let's say you have 10 data. Okay, 2 data will be used to test and another 8 data will be used to train the model. Okay, that's the idea. That is the proper portion to train the machine learning model. 80% of the data should be used for training and 20% should be used for testing, or 60 to 70 70 to 80% should be used for training and another 30 or 20 or 30% should be used for testing, right? So once we run this one, so this one is to predict our model. Okay, this one to score. So we just using the accuracy underscore our output test and the prediction. Okay, this one has been used for test by using this one and compare with our prediction result, right? And then we can have the score. So far our score is 1.0, which means 100% of accuracy. Okay, let's say you run this one. Okay, so now it's turned to 0.75. I run again. So the score will be different. Why? Because when we train the data, right here, right, when we train the data, 20% for train data portion test, basically the numbers of data that be taken from our data set is random. Okay, this is how it happens. Let's say you have the data from number 1 until 10, right? Maybe the first run, the training data, the Python take from the bottom, 2 data from the bottom, right? And maybe the next run, the next cycle, the data for training, it take from 2 from the top. Okay, so it's a random. That's why the accuracy is different. But if you keep running this one, you can see you you repeat the process to show to observe the accuracy, to analyze the accuracy. If the accuracy is always fluctuate between 75 to 1% to 100%, 75, 80%, so it's over the range of acceptable. So this range of accuracy is acceptable. It's up to you. You define, right? So far, in this case, it's acceptable. So it's meaning your data is sufficient and your training model that you choose is sufficient. so that you can deploy your machine learning model for another type of application. Okay, so any question, Tengku Amira? Okay, so let's try another one. So before we move to this one, let's try another one. The same project, okay, the same machine learning model concept, but this one is using for project number 2, which is to predict the score based on learning hours. Okay, so we have a lot of data we collected from our student, for example. Okay, we want to predict what is the expected result that the student will get based on their learning hours. Okay, so we have collected the data. So we collected data based on hours and the score result so far. Okay, so we want to have this database so that we can predict the expected result later, right? So the data has been stored in this file score.csv, which is the same folder where we run this Jupyter Notebook. And then this is the import Panda SPD, which is the first step we need to do to import the library Panda to Python, so that our Python can use to operate the number, to program the number, to rearrange the numbers, so that we need the library. Okay, once we import the library so that we can process the data, then we can use this library, okay, PD, which is Panda, to read our file. Okay, what file name? Score.csv. Okay, and then we just call our file that has been read in Python has been pumped under this variable, which is mark. Okay, this mark is the data set that we have. Okay, the hours and the score, right? So as you can see here, it show you our data have 96 rows and 2 columns, right? Now the second step, when we upload the data, right, when we import the data, so we need to prepare the data. But at the moment our data is quite okay, no problem. Then we can go to the next step, which is to split data for training and testing. Okay, for training and testing. Okay, to split data for training and testing, right? So we can use the previous method where we drop the specific column or specific column where we don't want. So in this case, we need to use the hours column as an input and the score column as an output. So since we need to set the input first, so we need to drop this column, right? We need to drop this score column. So to drop this score column, we just call our variable marks, which is contain the data set, and then we're going to drop. Okay, we're going to drop the score column, and then we're going to park this one under input we call x. So when we run this one, okay, so this one we have this input. Okay, let's me run this one. Okay, so we have this input. Okay, now x is hours where we have this all data. Okay, the next one we need to define the output because we already defined the input. Okay, we need to define the output. We just call this our data set, okay, and mention which column that we want as an output. Okay, in this case we need the score column, and then we park under y variable. Okay, so this is output. Now we already have the input and the output. Okay, so what is the next step? The next step, we can proceed with the training and prediction. Okay, training and prediction. So we can use the same library. Okay, we just call this library as sklearn.tree. Okay, under this tree library we have this algorithm. Okay, this model, decision tree classifier model. Okay, and then we can use this model. Okay, we use this decision tree classifier, we park the model. Okay, and then we can use the model to feed with our input and our output. Okay, and then we call our data so that we can predict. Okay, we can predict our input. Okay, let's say previously this one is 3 hours and 8 hours. Okay, 3 hours. Okay, basically 3 hours should be around here, should be the score should be in between, right? And 8 hours should be the score should be in between here. Okay, here. So let's run this program. So we run this one, right? Run all. Okay, so this one not a model, so this one is okay, this music data is from the previous program, so we use the mark, right? Mark file, mark variable. So now, the input is 3 hours, the score that should get is 27%, for example. And if he or she study 8 hours, the result should be 79. So that is the idea of this machine learning model, where we can predict the data in between, or we can predict data that beyond the data set. Okay, but the data set must the input must be close with the data set, right? Okay, so let's try this one, maybe 10 hours. Okay, maybe you can use this one, 15 hours. Okay, how about this one, 20 hours. So let's run this one. So this one, so if he or she study longer, so they should get result as very high, 99 and 99%. Okay, so that is the idea how we can use the machine learning model to predict the data in between. Okay, now the next one is I'm going to this one, right? So we already able to complete the project one, where we to predict the favorite genre based on gender and age. And then the next one, we able to use the same machine learning model but different practice. We can predict the score or result based on learning hours. Okay, next one, we going to use the machine learning model in Python to predict the house price based on house size. Okay, based on the house size, right? Okay, so let me close this one. Okay. Okay. So come back to your Jupyter notebook, okay, and then you go to your desktop. If you save your file in your desktop, and go to the folder that you just created before, okay. In this case, the data that I'm just using to develop to predict the house price is here, okay, in this folder. Okay, so let's say I run this one. Okay, so this are the data that I have. Okay, so let's open this one. Okay, so let's predict the price of house. So this is your data, right? This is your data. Okay, so I have, if my size, my house size is 300 square feet, so the actual price is 80,000, for example. If the 500 square feet, the price is 130k, and then so on until up to 2,200 square feet, the price of house will be 422, right? So we want to predict, we want to develop the machine learning model that able to predict this price, the house price, based on the size of square feet. Okay, so since let's say your data here, okay, your data here, so let's say you want to develop the new Jupyter notebook, okay, in this folder. So you go here, new, and Python 3 IP kernel. So now you can develop your program, okay, your machine learning model, Jupyter notebook, where that have the same location with your data set, right? Okay, so let's run this one. Okay, So this one just to ignore any error. Okay, so this is the data that I just copy down from this table. Okay, as mentioned before, right? So when we have the data, right, and then we can import the data, right? But in this case, I just to rewrite again the data straightforward in my Jupyter notebook. Okay, I've done import. Okay, I just want to show you how we can replicate the data directly from Jupyter notebook page. Okay, no need to import because we only have 9 data, then it's not so hard to just to duplicate the numbers, right? Okay, to duplicate the number you need to using the based on the array function. So this one is how you can the array syntax, right? So this one is an input, okay, and this one is output. Okay, we want to test our model letter based on the size of your house and what is the price of the house, right? So far, if the price is 300, the price should be 80,000, and if the price of the house is 2,200 square feet, okay, and the price should be 420k, for example. So I just replicate the numbers, okay, and then this one is x, okay, this value, okay, same value here. This one represent x. I park this value, okay, I park this value under x variable, okay, and then the y is this value which is the price of the house, okay, under this one, okay. So in this one, I'm going to import the matplotlib pyplot, okay, which is the library allow you to plot the data. Okay, so I simplify this whole library name into PLT so that I no need to spell the whole thing in the next program. So I just using the PLT.figure, I put the title, put the label, put the x-axis label, y-axis label, and so on, and then I plot the x and y. Okay, I plotting the value of x and y value. Okay, and then using this dot bullet point with the magenta color. So if you're using K, for example, then you can the bullet point will be changed into black. Okay, so we have the code color here. If Y, we get to yellow, right? If blue, I think go to the B, go into blue. Okay, so up to you. If you change this one into this one, you can explore later in the matplotlib library. So you are free to explore this one. Okay, at the moment I'm just using the dot. Okay, so this one is the data set that I'm just plotting to show you the relationship between the size of the house with the price. Okay, so because remember we need to understand the data pattern first. Okay, we need to understand the data pattern first because our data quite simple here. For example, so as you can see here, the data of the price of the house is proportional with the size of the house. Okay, as you can see here, the plot data seem show you a proportional relation. So if the size of the house increase, the price of the house also increase. So that when we want to develop the machine learning model, we can use this relationship. Because when we understand this relationship, then we can choose what is the model that we can use from the machine learning library. Okay, so for this kind of relationship, okay, pattern, so we can use the linear regression because the proportional of the price of the house, okay, is quite linear, right? You can see here the pattern is quite linear. So then we can use the linear regression. So we need to import, okay, the linear regression algorithm from linear model. So we import this algorithm from this model. Okay, and then this algorithm or this model, okay, I put under model name. So next time I'm just typing model, okay, and then I'm just training. Okay, I'm feed this linear regression with my input and output. which is the price of the size of the house with the price of the house, right? Okay, so now I just predict this one. Okay, so you can see here why I've choose the linear regression, because you can see here the trend line show is quite straight, right? So it represent the whole data, so it means we can use the linear regression, right? Okay, so now after we fit this model, so then we can predict, okay, we can predict our house price. Okay, so this one I'm going to predict this one based on two house size, which is 300 and 2200 square feet. Okay, as you can see here, if 300, the actual price should be 80,000, and if the size square feet of your house is 2200, the price should be 420 something. So when I run this one, for example, so the price of the house is 133 and 476. Okay, so this is the result of prediction. Okay, so now as you can see here, so far our machine learning model can predict the house quite correctly. Okay, so this one for 120 we get 476, this one 300 something we get for 300 square feet the price should be 80,000, we get 100 something, right? 130 something. So it's not so good, but is the result is quite close. It will not so good because we choose the linear regression. Okay, we choose the linear regression. Of course, that's why we need to improve further. When you want, let's say you want to have a more accurate machine learning model, then you can choose another type of algorithm. But this one just to show you what if you can use the linear regression, just to show you the step of the programming, so that you can develop your machine learning model, so that you can understand what is the first step, import the data, the second step is to prepare the data, third step is to split the data into training and testing, right? And then you can import the model, train the model, and test the model. Okay, now we at the test the model. Let's say you can try this one for 150, this one for 1000 square feet, for example. Okay, so the price should be for 350 square feet should be 142, and then 1000 square feet should be 259,000. Okay, so this one, okay, close this one, okay, around this range. Okay, so that is the process if you want to develop the machine learning model to predict the house price. Okay, so as you can see here, the price of the house is 142 point something. There are a lot of numbers behind this point, right? So it's not very nice because we know the price should be only 2 decimal. So we need to format it. Okay, we need to use the format the number to display 2 decimal, because we only want to show 2 decimal point, right? So what we need to do is we can use this one, okay, around this one to format decimal equal to 2, right? And then we just run this one. Can we have this one, okay, from 142.163 to 5353 we reduce to only 0.16. The same thing goes for this one, 259.545 and so on, only 2 decimal points. So this one is make more sense because it's easier to observe and reflect more actual price, more actual house price. Okay, right? Okay, next one is to make it more meaningful to you. We can put something, the currency value. Okay, the currency. So in this case, let's say I want to use the Ringgit Malaysia, can just using this coding, okay, slash the 2F, which is 2 decimal point, and then I include this ringgit Malaysia string into my output. Okay, so once I run this one, so now the same result I can get 142.16 with the currency name, which is ringgit Malaysia, or we want to change to US dollar, maybe to Turkey Lira for example, or euro, so up to you. So this is how you can to combine the numbers with the string. Okay, so in this result we are able to predict our house price based on input, which is the square feet size. Okay, so this one, okay, so this is just a process so that we can predict the house price. Any questions so far, Tengku Amira? Okay, so far this is a result we can use to develop the machine learning model. So I hope you remember, okay, the main process how to develop the machine learning model. Okay, if you don't have any more questions, let's go to the project number 4, which is to predict the type of flower iris species. Okay, let's close this one. Okay, this one. So this one. Okay. Okay. So this is the iris flower. Okay, we have iris flower. Okay, and then this iris flower we have different type of species, which is called Setosa, versicolor, and virginica. Okay, it's quite common and obvious. We can predict or we can guess species of this flower by using the image recognition, because if we using the image recognition, we can based on the shape, based on the color, and so on. But what if we don't have that option? We still can predict the species of the flower by using the numbers. Okay, so how we can extract the features from this flower so that we can predict the correct species. Okay, since Setosa, versicolor, and virginica have a different size, so we can use the features, the parameter, as a data set, right? So for this iris flower, so we have two types of flower, two parts. The first one is a petal, and the second one is a sepal. So the petal is the sepal. The sepal is where the type of flower that the location is the outside of the flower, where this is the flower has brighter color to attract the butterfly to come. Okay, and then the petal is where is the flower not really matured yet to open to attract the butterfly or the bugs, but the function is to protect the inner part of the flower. Okay, so based on the study, so we can predict the iris species based on the size of the petal and the size of the sepal. Okay, so in this one, so the scientists already collected the data. They measure the petal size of petal and the size of sepal. Okay, based on the length and the width. Based on the data, they can see if the sepaling and the sepal width and the petaling and the petal width is kind of range. So we can class label or we can identify this one is a Setosa types. But at this range, for example, we can classify this species is the versicolor. And another measurement, okay, if the sepal length and the sepal width, and if the sepal size and the petal size fall under this category, so basically the species is the virginica. So this is the attribute or the value that we just collected from this flower, so that we can classify what is the species of the flower. Okay, let's say you have this data, right? Okay, that's your data set, right? This iris, right? You have data set, and then you want to create, okay, you want to create your program. Okay, so this one is, okay, so you go this one, okay, go this one, Python 3 Articuno, so that you want to create the new page Jupyter Notebook, so that you can call you can develop the machine learning model to classify type of iris flower. Okay, what is the first step? Okay, what is the first step? Tengku Amira, any question? Okay, the first step is we import the library first. Okay, because our data, of course, the first step we import the data first. But to import the data, so that to allow the Python to import the data, we need the library, so that the Python can do that, can do the job. So we need to import the library first. So we need to import the pandas library. So the panda is the necessary, the compulsory library that you need to use if you want to develop the machine learning model when the data set is based on the numerical numbers. Okay, so the first one we need to import the panda SPD. Okay, now I already import the panda library, and the next one is I want to import the maybe I want to plot data, so I'm using the matplotlib library. Okay, matplotlib pyplot. Okay, SPLT. So I'm importing two library, the panda library and the plotting library. Okay, so you also can use the import seaborn, which is another type of plotting library. Okay, another type of plotting library. Okay, so you can choose either one, so both you can use. Okay, and then you can use this one SNS dot set this one to make it, okay, to make sure your plotting color look nice. Okay, can be white. Okay, and color. Okay, right. So the next one is you need to call the data. So I just call iris. Okay, equal pd. Okay, so far let's run this one to make sure the coding is correct. Okay, no problem, right? So this is a type of species that we want to. Okay, let's go this one. Okay, iris pd dot write. We read our CSV file. Okay, so we need just mention where is our location of our data set. So our data set is location at this folder. Okay, remember, so our data set is here, capital letter iris.csv. Okay, under this folder data set. So but now my program will be here, so just calling the data set based on the directory path. Okay, then should be okay. So we just call this one iris. Okay, dot head. Okay, this one first. Okay, iris equal to pd dot write underscore csv. Okay, so maybe we don't need this one. Okay, so this is the data from this file iris.csv. So we have 150 row. Okay, we have 150 row of data with the 6 column. 6 column, 1 column, second, third, fourth, fifth, and 6th. Okay, so we have 6 column with 150 row. So if I just want to show, let's say I just want to show only few row, just using the iris.head. Okay, iris.head. Okay, so I'm just calling this variable where the data set, this one is part under iris. So only for head. So if I run this one, so it only show the first 5 data only, instead to show all of them. Okay, so it show only first 5 data. At least we get quick information what is data looks like. Okay, So now is our column data. Okay. So next one is, let's say I want to iris. Okay, I want to study to show how many data for each species. Okay, because we have 3 species, right? We have Setosa species, we have versicolor species, and we have Virginica species, and all the petal and the saddle size has been data has been saved under iris dataset. So how many data for Setosa? How many data for the versicolor? How many data for the Virginica? So we need to find out. Okay, I'm just calling this one. Okay, species. Okay, I'm calling this header. Okay, for each value count. Okay, using this function. Okay, count. Iris species E. Okay. So it means for Setosa, for this one, okay, Setosa, I have 50 data, which means maybe 50 row. Okay, versicolor species I have 50 row, and then the Virginica species I have 50 row as well. That's why we have 150 row. So we have a quite balanced data set for each species, each category. Okay, right? Any questions so far? Okay, so let's say if you want to see the data, you just call this one. Sorry. So you can see all the data that we want, as mentioned before. Now, let's say we want to see the data pattern. Want to see the pattern, so C, S and S. Okay, facet grid. Okay, we want to iris. Okay, hue equal to species. Okay, and then comma, we high. Okay, equal to 6. Okay, maybe then next map, we want to map. Okay, plt dot scatter. Okay, and petal. Right, so I can write this one, so it's too long, so just write this one to show you how we can plotting the data. Okay, okay, so now we already see a pattern. Okay, for each species, for Setosa, versicolor and Virginica. Okay, based on the category of sepal size and petal size. Okay, as you can see here, we can see a obvious distinct species based on their dimension. So it means we can use this dimension as a data to predict the size or to predict the species of the flower. Okay, to show you how obvious the data is, for Setosa it will be easier because all the data is not overlap with other species. Okay, as you can see here, the sepal size for Setosa is in this category, but the petal length for Setosa is quite small. So as you can see here, the Setosa data is not overlap with this category, with this species, but some of the petal, some of the species for versicolor and Virginica is overlap based on data set, because as you can see here, the data has been overlapped. So of course there is no accuracy or not really absolute accurate machine learning model. So we need to find another factor so that it can help us to develop a better machine learning model. So if we at the moment because we just only the dimension of the petal and the sepal size, so we can try to develop a machine learning model that try to predict what kind of the species of the flower. Okay, now, so since we have this one, Okay, now we want to just to show you what is the, this one not important. Okay. Okay, so basically we just want, so once we already see the data, right? Okay, we already see the data, and then we only understand that we can use this data pattern to identify the species. Then we can choose the model that we want. So since this one based on the category, based on grouping, okay, we can use the logistic regression. Okay, we can use the logistic regression. Why? Because as you can see here, the data for Sentosa, the data pattern is quite linear. Okay, quite linear. So we have the same pattern, so we can use the regression, logic regression. Okay, right? So we can use this one. Okay, we apply the library, right? We apply the library. So we apply the library sklearn.linear model under this library, right? And then we park under this algorithm, this model, under this model, and then we can try to fit, okay, to fit this model with our data, which is S and Y. Okay, S and Y. Okay, and then this one as moment, so we already run this one. Okay, so our data has been trained to fit with the input and output with X and Y value. Okay, so the quick way we can to measure the accuracy of our model, we just using the score, straightforward. And at this moment, for this data, our model for logistic regression fit with our current data, it show the score is 97%. Okay, so we can use this one just to show you how precision and how precision our data is. Okay, so then we can use this one to fit with our data. Okay, again this one. Okay, so from this one we import our logistic regression under this library, and then we import the Panda as our library to operate the data, to manage the data. Okay, and then this logistic regression algorithm part of the model. Okay, and then just recall back all the S value, right, and the Y value. Okay, so all the sample size in terms of length and width, okay, petal length and width, all the values, and Y as a species. Okay, so now we have the S as an input and Y as an output. Okay, input is the sample size and the petal size. Okay, and then based on data we can fit this model for this input and output, right? And then this one is our prediction. Okay, this one our prediction. Okay, so we can play around with what the value of sample size, sample line, what the value of the sample width, what the value of the petal length and the petal width, and then by using this prediction we can predict what is the species of our flower. Okay, so let's run this one. Okay, so at this moment, so the type of flower is Sentosa. Okay, the type of flower is, so let's change this one. Okay, let's say I have some recorded data here, so I do no need to scroll up to observe the data. So if the this is based on the data set, right? So if the sample length is 50, for example, okay, 50, the sample length is 50. Okay, and then the sample width size is 6.4. Okay, and then the petal length should be 4.5, let's say. Okay, and then the petal width, the size should be 1.2. Okay, based on data set, it should be versicolor species. Okay, now Based on this one, based on our learning model, should be our prediction will give you the answer either 0, 1 or 2. So I need to map this 0, 1 or 2 so that we can know what is the prediction. Is it the Setosa, is it the versicolor or the Virginica? So I need to mapping and say run this one. So now is the versicolor. Okay, if I don't do this coding, so it only give you the value of 0 or 1 or 2, that's all. So it's not really friendly output. So you just converted back from this numerical into string, okay, so that we can have the nice output, right? So we just give this input 50 for sepal length, sepal width 6.4, petal length 4.5, and petal width 1.2. So based on the database, it should be the versicolor species. And yet, of course, so far our machine learning model able to predict accurately. So let's try another one. This based on our data set. So the sepal length should be 5.9, the sepal width should be 3.0 and so on. So let's fill up the form, fill up the space. So sepal length should be 5.9. Okay. Sepal width should be 3.0. Okay. Petal length should be 5.0. And then the petal width should be 1.8. Okay. So based on data set, it should be Virginica, right? So let's try. Yes, our learning model able to predict accurately. So far, our machine learning model already has been trained and successfully predict the species correctly. So you can play around. Let's say you just want to develop a system or a machine or a sensor or software that able to predict the species of flower by just key in the size of the sepal size and the petal size. So you can play around. Let's say this one is 40, this one is 12, this one for example is 3, right? And this one is 2 or 4, for example. Then you run. It give you the species. What is the species that based on data set, right? So this is how you can use the machine learning model, okay, to predict the subspecies of the flower. So far I already show you how to apply the machine learning model in Python, a basic programming to predict the favorite genre based on gender and age, to predict the score based on learning hours, to predict the house price based on the house size, and to predict the type of flower species based on the sepal and the petal size, right? By using the machine learning model in Python, okay, by using the library from the sklearn. Okay, so if you remember the whole process, if you want to develop the machine learning model, basically first you need to understand your data first, and then what is your purpose? What is your purpose of develop the machine learning model? Because this is important, because you need to understand your purpose of machine learning model so that you can plan the data that you need to collect. Or if you already have the data they given to you, and then you need to understand the data, how the data looks like in terms of pattern, in terms of the correlation and so on, and then you can understand based on this data what you can do, what kind of the machine learning model, and what kind of the machine learning that you can develop. Okay, so once you already understand your data and understand your purpose, then you can import the library. What kind of the library that you want to import? Okay, this one, and then after you import the library, this one is under category basically is the Panda library, and then the library to plot the data and so on. So once you import the necessary library to allow the Python to process the data, then you can load the data and then prepare data, right? Maybe you can clean. If data is not nicely arranged, you can rearrange. If some of the data is missing, then you can delete some of the row, or delete some of the not necessary column and so on. After that, you can choose the model. So because you already understand your data, how data look like, and what is your purpose, then you can choose the model correctly. Okay, to choose the model correctly, this very important because you need to understand the big picture of algorithm first. So basically, before you develop machine learning model, you need to understand first what is the machine learning algorithm, what is the machine learning approach. Is it supervised, is it unsupervised, or reinforced? If supervised, like this today sharing, is supervised, how many type of algorithm there are. So what is the specific function for each algorithm, because it will affect your prediction result. So when you choose the model, then you can start to train the model. Okay, to train the model based on your data. So once it's completed, then you can test your machine learning model, or you can test to predict the result. Okay, once you get the result, and then you can start to improve your machine learning model by evaluating how about the score, how about the accuracy. So if the result is not sufficient or maybe not accurate enough, then you can plan to have more data, for example. Okay, or maybe you can choose another algorithm, for example. So remember, like the first project, right? For this project, so we may have developed accurate model, we have high score, but even though we have the accurate model and high score, but that model may be not applicable in actual application. Why? Because in this project you have only one input, for example, the age only. So maybe the data and the output you nicely collect, sufficient for you to, but the prediction system, the machine learning system will maybe not predict correctly, because there are another important data that you need to consider in your machine learning model. That's why for project 1, not only the age, you also need to import another important data, which is the gender, because the gender also the obvious parameter, the significant parameter that affect the favorite of genre or favorite of entertainment, right? So we need to understand. That's why you need to understand you need to understand data, understand your data. You need to understand your purpose of prediction or your machine learning model, and of course you need to understand the big picture of your application, because it will affect to determine you what kind of data that you want to use and what is the model you are going to choose to train the machine learning model. These are very important, because even though maybe you have the accurate model, but it's not applicable because the category of data that you use to train your model maybe not enough. Even though it's a high accuracy, high score, but the number of input, for example, in this case, is not sufficient. You need more than that, for example, to have a good machine learning model. Okay. So, Tuku Amira Yasmin, any question? Okay. So I have another few of program you are to show to you. So, for example, this one, just go this one very fast, just to show you the concept of the data learning model, so that you have many reference, okay, you have many exposure, so that when you want to exercise by yourself, so it give you some of the convenience, right? So this one is still using the linear regression algorithm, right? But this one is I want to predict the car price. Okay, I want to predict the car price based on the engine size. Okay, so this data is coming from this car underscore data set. Okay, so when I upload this car data set, right, so I have this lot of data. I have this ID, I have the symbol, I have the name of the car, I have the fuel type of each car, the number, the car body type, drive wheel, and so on, engine size, okay, the horsepower, and so on. So I want to use this parameter to predict the car price. Okay, so This one is if you want to understand the basic statistic info of your data, right? For example, in term category of the engine size, what is the maximum engine size available in data? What is the minimum engine size? So you can see here, so if I use the describe function, so it gives me the basic or some brief statistic info for the data. So now for engine size category, for example, now I know how many car, how many engine. Basically in this data we have 205 engine, okay, and then the maximum engine size is 300 to 26, and then the minimum engine size is 61, okay. The same thing for the car length, for example, the length of the car, how many car, of course 205, right? And then the maximum of the car length is 208, and the minimum of car length is 141, and then the average of them is basically the average of the car length of the car is around 174. So we have this sum of brief information by using the describe function, okay. Right, so now because I have a lot of data, so some of the column I don't need because it's too much, okay. So maybe I just want to drop something, okay, so I just need to prepare the data, okay. So I just select few parameter, okay. In this one just only one parameter. I will just want to predict the car price by using the engine size. So you already experienced this before. Based on explanation, you can select which header or which column. So in this category, on this project, in this machine learning model, I choose this column, engine size and the price, okay. So this one I punk under new data frame, and under one variable new data frame. So this new data frame, new underscore df, have this information, the engine size and the price. So now I can split the data, right? I can split data, engine size as an input and the price as the output, so that I can use the engine size as a data to predict what is the car price, okay. Now let's see the data pattern first. Is it proportional? Okay, so I just plot the data, the relationship between the engine size and the price. As you can see here, this data, the relationship, okay, between engine size and price is quite proportional. So basically, if the engine size is higher, the price will be higher as well. So it shows some kind of the proportional relationship. Okay, so that's one. So it means this data is quite useful. Okay, even though some of the size give you quite high range of the price, okay, quite broad, but in general, for big overview, this data still can be used to predict the car price, right? Let's say you want to compare with something else, with another parameter, between the price or between the car price with the fuel types. So basically the car only two types of fuel, either gas or diesel. So if you want to use the fuel types as an input parameter to predict the car price, so it's quite difficult. Not quite difficult, it's difficult. So it's not correct, because the response, as you can see here, the data pattern don't show any correlationship between the fuel type and the price, right? So therefore, compare these two, between the engine size and the fuel type, definitely the engine size is more reasonable for you to choose to develop the machine learning model to predict the car price. Okay, so that's why you need to understand your data first. You need to understand data characteristic first. Okay, so plotting is one of the way to understand the data relationship, aside of the statistic info, right? Maybe some features and so on. So plotting is a very straightforward, very fast way to observe the relationship of the data. So by using the plotlib, okay, by using the plotting data, now you can see the relationship between the engine size and fuel type with the price. Okay, so based on this one, so obviously we can use the engine size and the price is more reasonable, more accurately. So we choose this data type. So now engine size as an input and the price is the output. Okay. Now I can use this one. Okay, I'm using this model from this library, sklearn library. Okay, under linear model library, and then I can download this one. I can use this algorithm, linear regression algorithm. So I'm using this one to train the model. So basically, this is the result that I get. Okay, the actual one and the predicted value. So it's still proportional. Okay, so let's go down here. So you can see here. So I can predict the car price with the engine size. Okay, let's say the engine size is 152 and 1.154. So the price is 90,000 and 50,000 something. So we can predict the price based on the engine size. So as you can see here, the whole idea is same. Okay, the whole step is same. You need to understand the data, import the data, prepare the data, train the data. Okay, and then you can test and then evaluate. Right? So only the data will be different, but the step is same. So you can explore better, okay, using the different library, different data set, different algorithm. Let's say this one, okay, we may have we have a different parameter here. So based on logic, what is the other parameter that affect the car price aside of the engine size? It's probably what we call maybe the horsepower, right? Horsepower. So horsepower and engine size is another important parameter that we can use to predict the car price more accurately. Okay, so you can explore later to compare with the single input and double input and see the score, which one can score higher, either in one input or single input. Okay, and maybe you can try to experiment yourself, to experiment, choose the wrong parameter and see how the score will be dropped. Okay, so this way you can explore yourself and then you can understand why you need to understand the data first. So this way, so this is to mention that to understand the data is very important. That's why aside of the machine learning algorithm, machine learning process, you still need to explore on data analysis fundamental. That's why you need to explore more on the aside of the machine learning model, you need to understand the data analytic part. Okay, so this one you need to engage or you need to study the data analytic aside of the machine learning. So these two knowledge is compatible. Okay, you need the data analytic fundamental so that you understand the data, so that it become useful to you to produce the optimum machine learning model. Okay, so basically so far this is my sharing today to Tengku Amira and other participant. So basically I've already explained to you the step by step how to develop the machine learning by using the Python. So I've shared with you, I think the 5 project, okay, and all of them using the same principle but different application. So by repeating the same process of Python programming, I hope all the participants now can remember, can understand the process flow to develop the machine learning algorithm. So this is the linear regression and so on is only one of the method of machine learning model based on the numbers, okay, based on numerical. So if we want to develop another type of application, for example the machine learning model based on image processing, or maybe based on video recognition, or for the text, for the audio, so we need different type of library. Okay, so basically we need another type of library, maybe for another one for classification, right? Classification types. Okay, and maybe we need another type of algorithm as well. So we need to explore this one step by step. Okay, so the purpose of this sharing to share with you with the same study case, the same concept study case, even though different application, but same problem based on the same data concept, data input, so that you can repeat, iterate the understanding by have a different type of project. Okay. So I think that's all for today. Tengku Amira, any questions? Okay. If there is no more question, I over to you, Mr. Nasim. Tengku Amira, ada soalan?
Well, Dr. Carol, I know that you finished your call for today, right?
Yes.
Okay, that was an insightful and informative session. Okay, thank you, Dr. Carol. Okay, thank you, everyone. If you wish to join the classes by Dr. Carol, you can always follow us on aeroblogsteacher.com. And those on the upcoming topic from Dr. Carol or other channel, those hang up in our Skillshare platform for more learning. But actually, QR code I shared earlier in the chat box. And also don't forget to give rating for today's evaluation, today's courses at the Skillshare website. Okay, that's all from me. And once again, thank you so much, Dr. Carol, for today's class.
Okay, thank you.
Okay, see you again, Dr. Carol.
Okay. See you again.
Assalamualaikum.
Assalamualaikum warahmatullahi.